Okay, next section is extending the rule. So, if you follow the SIA notes alongside mine, I have them open here on the phone. So the first one is y equals 1 over x. You can't differentiate in the bottom line, so you must bring it up as x to the minus 1. Now you can differentiate it. Part 2, y equals x squared root x. So that's x squared. Root is a power of a half. Remember the rule of your multiplying numbers, you add the powers. So that's 2.5 or 5 over 2. Now you can differentiate it. Power to the front and take 1 off. This one here is y equals 1 over root x. So it's 1 over x to the half, which is the same as x to the minus half, and then you can differentiate it. Number 2, on the SIA notes, I've written out, is differentiate this. So first of all, you have to expand out this bracket. That is x to the half. So it's 3 times x to the half minus, that's 2x to the 1 times x to the half. Multiplying numbers, add the indices. So 1 add a half is 1.5 or 3 over 2. Then multiplying these two out. So it's minus x2 times x to the half. Add the indices, so it's 2.5 or 5 over 2. Then just differentiate your normal way to power to the front and take 1 off. Number 2, you split that up. So it's 3x over x5. So that's x to the 1 over x to the 5. So subtract them to give you minus 4. X to 2 over x to 3. Subtract them to give you x to the minus 3. And then differentiate. Power goes to front and subtract 1. Now, for this one here, number 3, you have to find the gradient and then the equation of the tangent and equation of the normal. So here's your curve. Write it as y equals x to the half. Differentiate it to get the gradient. Now, I wrote it a wee bit neater there. I just brought that x back in the bottom row. So it's 1 over 2 root x. Put in 4 to get the gradient. Equation of the tangent. Y minus y1 equals mx minus x1. You're told the point. So put in your x value is 4, your y value is 2, your gradient you've just worked out, and what I did there is times everything by 4. So 4y minus 8 equals 3x minus 3 times 4, and then just tidy it up. Part 3 is what in the equation of a normal. So write it out. Y minus y1 equals minus 1 over m, x minus x1. Put in your x coordinate is 4, your y coordinate is 2, your m from up above is 3/4. Now, 1 over a fraction is the same as turning it upside down. Then I multiplied by 3, so 3y minus 6, that gets rid of that 3. Then minus 4x plus 16, and just tidied it up. Example 4 from the notes is find the stationary points or the turning points of this. Remember, stationary points and turning points are the same thing. First of all, this needs split up. So it's x2 over x3 minus 3 over x3. So divide numbers, subtract the indices, gives you x to the minus 1. Bring your x up, so it's x to the minus 3, because you cannot differentiate anything in the bottom row there. Now you've got the right form, you can differentiate. So power to the front and take 1 off. And I wrote it a wee bit neater. So minus 1, just popping the x squared back down the bottom, plus 9 over x to the 4. Turning point is when the gradient equals 0. So put this equal to 0. I brought this to the far side. You've got a fraction equals a fraction, so you can cross multiply. So 9x squared equals x4. Put everything on one side. Factors out your x2. Then you've got the difference of two squares. So you've got your answers there. X is 0, x is 3, x is minus 3. Now, let's work out what the y coordinates are. So putting in x equals 0, you get a y with a 0 in the bottom line, which is impossible. Put in x to be 3. So putting in x to 3 into your y gives you 2/9. I'll come back to the second derivative in a second, just ignore that bit. Put in x to the minus 3, and you get your y to be minus 2/9. To find the nature, differentiate again. So up here I've got the first derivative. Differentiate that again. There, it's over there. I was trying to find where I had it. So differentiate it again. And I wrote it a bit neater. So it's minus 2 over x3 minus 36 over x5. Then sub in your x's. So when x is 3, sub it in there. So it's 2 over 3 cubed, which is your minus 27. Take away 36 over 3 to the 5. It gives you a negative value, which is a maximum. Then sub in minus 3 into your second derivative. So it's 2 over minus 3 cubed minus that. And when you work that out, it gives you a negative. So it's down there. This is x equals minus 3. Your second derivative is a negative. Sorry, it works to be a positive. Sorry, minus cancel off. So it's a positive, which is a minimum value. So you've got your minimum turning point and your maximum turning point there. The next, that's the finish of those. So basically, a couple of things you should take from that. If you have an x on the bottom, you move it up as a negative. If you've got a root, you write it as a fraction. If you have two numbers multiplied, you've got to fix the indices using the indice rules. Multiplying two numbers, add the indices. If you're dividing two numbers over here, split them up and then subtract the indices.